Hello everyone, my name is Paul. I work for a company called Micrographics in Cape Town, South Africa. We are an Autodesk reseller. Today I'd like to focus during this video on a question that came my way from a client that had problems with how a roof anti-sag joint was being created on the side of a building. So what you will see on the screen is that we've got two columns and some purlins that are attached on, well, not attached with joints yet, but they're on the side of the building. And between the two columns, we would now like to use this anti-sag joint so that these purlins don't sag. And for that reason, this client had used the roof anti-sag connection. If you go to your connection vault, you will see that you've got a heading for purlins and cold rolled, and if you scroll down the list you will find the roof anti-sag joint. One of the nice things about this is if you expand the explanation, it will then give you an indication or a recipe about how you could go about creating this. You can see that this is typically meant for a roof, but you can use it given the members and the purlins. The selection order is important. That was the first problem that the client had. For the first input, it expects a support beam, meaning one of the columns. For the second, also a support beam, the second column, and then some rails. Those are mandatory. Then we've got optional eaves if we had been doing a roof. And then it gives a further explanation over here: support beams, any profile rails, any straight profile. Description: a series of struts and wires with connection cleats that are inserted between rails and eave beams in a building bay to form a generic restraint system. And then there are some options also that you can input there. So it's very much like the support system on a biplane. We've got two wings, one above the other, and then you've got these struts and wires that stop them from sagging. So let's execute this joint. We'll click on Roof Anti-Sag. Remember, the first input is the first column. We'll press enter. Then it will expect the next column, which we'll select and press enter, and then all the rails. So I'll click on 1, 2, 3 rails and press enter. Then, do you want to select eave beams? In this case, no. And do you want to select eaves brass cleats? No. What this now does is generate the connection, after which we will have a look at what we can do with the support wires, which was the specific query that this client had. So there we can see that the connection has been generated. Let's have a closer look at that. It's got one strut going top to bottom, and it's connected at the bottom and the top with bolts. These are obviously not arranged nicely at the moment. So let's then go further and select the joint. You can do that by just clicking on one of the members and then right clicking and saying Advanced Joint Properties. That will bring up the dialog for the properties. There are many settings that you can then adjust. I suggest that you keep it open on the side and then adjust as you go along. So the type is Roof Anti-Sag. And then there's the properties. Alright, we've also got a library of different sizes if you were to set that up. And then we'll get to the rods. So there you can see the layout. There are some design rules that you can use, or you can choose what you would like. So if you take that out, by rods they mean the struts. Let's just move this onto the side and we can see what we're doing. If I input a number of 3 over there, then it's got 3 items, and if I change distance 1 to 0, then you can see how they are equispaced from one side to the other. The angle that's getting used is a angle iron. You can of course also choose your own. So there, for instance, you can see that we've got SA angles. If you wanted to use some South African angles, then you can choose the side from there, size. Bottom cleats, top cleats, cleat chamfers, shims. So it's still not at the wire is at the bottom over there. The eave brace strut, if we had any, and then we get to the tie wire. And this is really where we are interested. So if you switch it on, then you can see that it puts wires down there. There's some wires. If we switch on the second set, then we've got wires at the top and at the bottom. And then you've got a choice about how you'd like to arrange them. If you say up, it changes the orientation. Down. And if you say none, then it takes them out. Right. So that's up to you how you'd like to have them arranged. However, you will see that you can have some shims there. But nowhere is there a connection that you can probably choose about how it connects to the bottom. And that's really the problem, is the client would have liked to be able to offset these wires and then to change the type of wire that it is. You can change the type of the wire, the tie wire. By changing the tie wire section. You'll see you've got available to you under the South African library, round bar or cold, and you can at least change the size if you want, but you're still restricted as to the type of section that you would like to use. So if you wanted to use a angle iron on the tie line, you wouldn't be allowed to do that. So just to tell you what the client ended up doing is he forwent the tie wires, and instead he modeled bracing to simulate that. So just that there are some limitations to the connections that you can generate within advanced steel. Obviously it doesn't cater so much towards customization within the existing connections, but you could always get rid of the connection and then try and model something that's closer to what you want. Maybe put it in the connection vault and reuse that. I hope this helps you, and until next time, enjoy advanced steel.